Hocam beklediğimiz birileri var mı? Başlıyor muyuz? Nasıl yapalım?
Başlayalım. Ramiz Hoca'ya ulaşamadık telefonda. Ramiz Hoca'yı sona aldık.
O
Tamamdır
zaman
hocam.
Meryem'le başlayacağız.
Tamamdır hocam. Ben sizin takdiminizi yaptıktan sonra çekiliyorum. Dear participants, we will continue with the last session of the second day. The chair of this session, Associate Professor Halide Nihal Açıkgöz from Ankara University. Miss Açıkgöz, we are waiting for you.
Okay. Hi, everyone. We have three speakers today. First speakers from Algeria. Associated Professor Dr. Meryem Talep. And we are listening to Meryem Talep now. Dear Meryem, please introduce yourself for our students and investigators. Meryem. Okay.
Herkese merhaba. Öncelikle beni davet ettiğiniz için teşekkür ederim. Çalıştayı organize edenleri de tebrik ediyorum.
Sesi biraz yükseltebilir miyiz acaba?
Efendim?
Sesinizi biraz daha yükseltebilir miyiz? Yaklaşabilir misiniz?
Of course. Okay. Good afternoon, everybody. My name is Dr. Meryem Talep, and I'm an associate professor at the University of Gidawaan, Algeria. May I start? Nihal Hocam?
Yes.
I start the presentation, okay? I'm starting.
Yes, please introduce yourself.
Yes, I said I'm Dr. Meryem Talep, and I'm an associate professor.
No, not enough.
Of...
You are the first investigator.
About forensic
entomology in your
okay. So
country.
I'm supposed to give. I'm supposed to give a brief statement on my research. Okay, so we have been working on forensic entomology in Algeria, and since my master's degree. After that, I came to Turkey to collaborate with Associate Professor Nihal Açıkgöz in forensic entomology. We have been since then working together and doing research related to, again, forensic entomology. So my research is basically the first, among the first in Algeria, and also among the first in North Africa on forensic entomology. In this presentation, I'd like to talk to you about biology education generally in Algeria. I've divided my presentation into three main parts. First of all, I'll talk about the higher education system and the organization of biological disciplines in Algeria. Second, I will share with you an example of the strategies I implement in teaching biology. And finally, after a brief conclusion, I will present the challenges facing biology education in Algeria, as well as some perspectives I find important. Let's start with the higher education system in Algeria. So the right of free education is guaranteed for all Algerians. The university sector comes right after compulsory education that takes place until the age of 16, offering different types of training to all baccalaureate holders, which is high school diploma in Algeria. There have been two main reforms of the sector. The 1971 reform that changed the structure of the universities, from institutes to faculties. And recently, the LMD reform that started in 2004 and was finalized in 2010. So LMD stands for Lisans, Master, Doctora. The introduction of the reform meant the change of the degree system into a license degree, the Algerian equivalent of bachelor's degree. It was reduced from 4 years to 3 years. The master's degrees, which replace the magister degree, and doctorate. This system offers a better readability of diplomas on the labor market. So the lessons and training received are measured in credits. The students have to collect 118 credits to obtain a bachelor's degree, 120 credits to obtain a master's degree. And the credits are collected from the grades obtained during the semester. For example, from theoretical courses, practical laboratory courses, internships, dissertation, or assignments. The training offer is built by a pedagogical team, and the bachelor or master's degree has a vocation either academic or professionalizing, which means the students who hold a professionalizing master's degree cannot pursue a PhD. To obtain a doctoral degree, doctoral education lasts a minimum of 3 years and maximum of 6 years. The doctoral student starts their dissertation in the first year after a theoretical training. They perform teaching activities each academic year. The doctoral student is assessed at the end of every academic year and before each re-enrollment. The doctorate dissertation consists in preparation by doctoral students of an original research work to be the subject of at least one publication in indexed journal with impact factor. After a favorable assessment of the application and after presenting a finalized dissertation with journal publications, the scientific council of the faculty approves the defense of the dissertation. As for the organization of biological disciplines in Algeria, for example, the University of Blidawan, which is located in north central Algeria, biology is taught at the Faculty of Nature and Life Sciences, which has 3 departments, which are Department of Biotechnology, Department of Agri-Food, and the Department of Biology. In the first year, students are taught a common curriculum in the domain of nature and life sciences. In the second year, students take the biological sciences stream. The other streams available at the faculty are focused on agricultural sciences. In the third year, students choose a specialty. And for master's education, they continue in the same specialty or in a related one. As for PhD programs, each year, program for maximum 8 students is launched, for example, in one of these specialties. Let's now turn to methods we use in our universities, focusing on my experience. I would like to mention that after assistant professors are appointed in Algeria, they have to go through a compulsory training course in information and communication technologies. So I use an etymological approach to teach biological terminology. I urge students to learn the etymology of biological terms, as each one is a compound word in Greek or Latin. When I find one that students know these roots, they can figure out what a word means, even if they never heard it before. This method helps also to remember the definition after learning it. So I believe that biology is not all about memorization. Students have to learn biology by understanding and not by merely rote memorization. Indeed, some things are to be memorized, but not whole of biology. It is a mixture having constituent concepts. So visualization is first and foremost thing in biology. For instance, students know that mosquitoes are flying insects that with piercing, sucking mouth parts. As in entomology, we teach the different types of mouth parts. For example, since they have seen many mosquitoes and beaten by probably thousands of them, they know this fact. So this is just a simple example. Imagination is another crucial part to learn biology. However, this is specifically for concepts. For example, it is not possible to see DNA transcription and translation taking place. For this matter, I showed students animated videos. I would like to also focus on a discussion, which is a very important part for learning biology, especially for concepts and minute things which can be forgotten easily. Discussion with peers and teachers is the best way to learn information that are difficult to remember, and even after reading them again and again. Moving on to the pedagogical methods I use: diagnostic, formative, and summative assessments. I perform a diagnostic assessment before starting the course. This allows me to test the mastery of the prior knowledge necessary for proper follow-up of the course by using formative assessments. After each unit, I identify the students' misconceptions, struggles, and learning gaps along the way and assess how to close those gaps. And of course, I use summative assessments at the conclusion of the course to evaluate the students' knowledge and success. Using Bloom's taxonomy, I write global objectives and as well as specific objectives at the beginning of each unit. This is how I choose learning activities that are consistent with objectives and with the approaches and methods adopted in the course. Articulating learning objectives help select and organize the course content. I also rely on visual mapping strategies for organizing and communicating knowledge. For example, this is a conceptual map that I use to present one of my courses. I also use mind maps to simplify complex ideas and to present a clear hierarchy such as taxonomy and concept maps to show patterns and relationships. So using PowerPoint slides I use are made available after class and sometimes before class via Moodle. This liberates students from the need to take notes on everything that is present. And this also allows time for critical thinking, questioning, and discussion based on information presented. I also upload the course material in PDF and SCORM formats, which are suitable for online education. As for the other tools, in designing assessments, notably exams or term papers and laboratory reports, I attempt to challenge the students to reach beyond the mere facts and to demonstrate critical thinking and a deeper understanding of the subject matter. For this purpose, I use predominantly essay and long answer exams, especially in the upper level and graduate courses. After exam, I provide the answers via Moodle for all written and work handed. I try to provide constructive criticism so that students are not merely earning a grade on these assignments. They can learn how to create an even better product and gain from this process. The communication tools we use are basically forums and chat rooms on Moodle and emails. However, I urge the student to share their questions on the forums so that everyone benefits from the answers and the discussion. So I make sure to meet the pedagogical alignment, which consists in the translation of objectives into learning outcomes, given the three dimensions of competence in terms of knowledge, which know-how and life skills. So the knowledge is acquired through the theoretical learning of concepts. The know-how is a practical experience which testifies to the technical mastery of a field and which allows the application of knowledge. The life skills are mostly about the behavior of the student in the group. These are the personal and behavioral qualities that will be reflected in the professional fields. For example, courtesy, control of emotions, good interpersonal skills, and so on. Therefore, I engage students by asking questions in the classroom, incorporating innovative laboratory sessions and challenging problem-solving projects, and encouraging peer-to-peer interaction through group work and study. My own research activities are an important part of my teaching as they provide an example of the scientific process in action performed by someone that students know. I find that students are fascinated when I present my research in class. Moreover, I have integrated my research into the curricula of the laboratory courses that I teach. In graduate courses, my students perform a semester-long project based on my research, whereas in upper division undergraduate courses, my students perform a series of mini projects, again, based on my research. So many of the projects performed in these laboratory exercises are novel, and students are excited to be given the opportunity to produce meaningful results. I believe that this approach, in which students perform actual experiments on related topics throughout a semester, brings a sense of ownership to their laboratory experience and results in much deeper understanding. To conclude, I'd like to say that at the core of all successful teaching in biology, it is the ability to convey the excitement of the subject to the students in the classroom and in the field, instilling in students a desire to learn more about the natural world. In this context, basic skills and principles in biology are taught as tools with which to scientifically address problems and to critically assess the existing state of knowledge, rather than as part of final set of facts that students are merely expected to memorize for a grade. As perspectives regarding Algeria, university failure is usually linked to the problem of the French language. In Algeria, dialectical Arabic known as Darija and Berber dialects, which are known as Tamazight, are the mother tongue of Algerians, one of them or both of them. So standard Arabic is the only official language of the country from primary to high school. And French is used in the teaching of technical and scientific courses in higher education. So the students are forced to take courses in a language which until then was officially taught as the first foreign language. For this reason, it would be interesting to teach biology courses or any technical courses in the language the students are used to, or at least offer them preparatory classes before they start studying biology or any other discipline in a foreign language. It would also be interesting to focus more on academic English courses. I would also like to add that the 3-year period for licence teaching in Nigeria is intense and seems to be not enough. Although most of the students continue masters, they should not be obliged to do or feel obliged to do so. I would like to highlight the role of laboratory courses in biology teaching, as laboratory studies can create a learning environment that encourage students to question, thereby fostering critical thinking. Students should be encouraged to work in small groups, leading to social interactions and peer teaching. So that brings me to the end of my presentation. Thank you for your listening.
Yes, okay. We listen to Mariam, and we want to pass our second speaker, Professor Dr. Wolfgang Nellen from Germany. Dear Dr. Nellen. We didn't say anything the hours of his presentation. I think for this reason he's not here. Dr. Nellen? Yes, he's not here. Okay, Dr. Shamado is here.
No.
No. Okay. I think we will wait for Nellen's, for Dr. Nellen's presentation hour, presentation time.
Approximately 20 minutes later.
Yes. Okay. Dear listener, if you want to ask any question, you can ask your questions by writing to the chat box on Zoom or YouTube. When you want.
Ben kontrol ediyorum YouTube'u. Henüz bir şey yok. Yalnız sizden şöyle bir soru sormanızı rica edebilir miyim? Cezayir'de biyologların örgütlenmesi ne şekilde oluyor? Cezayir'de bir biyolog örgütü var mı?
Miriam, are you here?
Yes. Cezayir'de yani dernek mi? Örgüt,
evet.
dernek.
Yes. Yes.
Evet, birkaç tane var. Bir de daha Cezayir'de daha da uzmanlaştırıyorlar bize biyolojide. Mesela mikrobiyoloji derneği, parazitoloji derneği, yani bir sürü var. Bir de öğrencilerin tabii biyoloji derneği de var. Yani var bir sürü dernek biyolojiyle ilgili.
Bize en azından bir tanesinin adresini verirse TBBA olarak ve akademi olarak iletişime geçmek isteriz.
Evet, olur. Tabii.
Meryem, bir şey söyledin. Öğrenci derneklerinden söz ettin. Öğrenci biyoloji derneklerinden. Öğrenciyken dernek üyeliği mi yapıyor çocuklar?
Evet. Öğrenciler...
Çok güzel bir şey, farklı bir şey.
Yani bilmiyorum, sanki Türkiye'de böyle bir şey olduğunu duymuşumdur. Yani ama burada sadece çalışmalar için değil, yani öğrencilerin hakları savunmak için, ya işte böyle genelde yapıyorlar. Mesela öğrencileri bu şikayet etmeye gidiyorlar, bu dernekleri. Yani öyle. Yani son 20 senedir falan hükümet öğrencilere daha çok dikkat ediyor. Öğrencilerin ne istiyor, şikayetleri, düşünceleri. Yani bu amaçla yapılıyor.
Evet, çok güzel bir sistem aslında. Bizde öğrenciler pek derneklerle içli dışlı olmuyorlar. Bir de öğrencilerin öğrenciyken derneğe üye olmaları duymadık, yapmadık biz öğrencilere. Aslında yapılması gerekiyor, değil mi abi?
Evet, 1970'lerde her fakültede öğrenci dernekleri vardı. İşte o daha sonra 80 sonrası bu öğrenci dernekleri kapatıldı. Onun yerine kulüp kurdular. O şekilde idare ediliyor şu anda.
Evet.
Halide hocam biz yavaş yavaş bunu yapmaya çalışıyoruz. İşte her üniversiteye birer junior biologist arkadaşımızı temsilci olarak yerleştirip o şekilde bütün üniversitelerden haberdar olmaya çalışıyoruz şu an.
Evet, aslında sizlerin bir araya gelmesiyle o kadar güzel çalışmalar ürer ki, o kadar güzel çalışmalar yapılır ki, yani aklımda olan kendi alanımla ilgili çalışmalarda da hani sizlere böyle yayılarak, ulaşarak çok güzel, Türkiye adına çok güzel çalışmalar yapılabilir. Hepinizin adının olduğu çok güzel çalışmalar yürütülebilir. Yani bu konuda
Hocam
organize olmanız da çok güzel olur.
tabii zaten özellikle okul topluluklarıyla da işbirliği içinde olduğumuz için, gerçi Beyza da burada, o daha iyi biliyor, daha detaylı biliyor fakat yani bütün genel olarak tabloyu şu an aşağı yukarı çıkartabiliyoruz. Her okulda ne yapılıyor, işte hangi etkinlik var, biz ona gidelim, onlar gelsin bizim etkinliğimize veya buluşalım bir yerlerde teknik gezi yapalım. O tarz bir Türkiye içinde bir yapılanma gibiyiz aslında burada, Türkiye Biyologlar Derneği'nin çatısı altında Junior Biologist projesi olarak. Okuldan, üniversitelerden bağımsız her okul, her üniversite böyle oldukça komplike bir yapı oluşturmaya başladık. Sayımız da giderek artıyor her geçen gün.
Evet,
Bir de
çok güzel.
Halide Hocam, bir de bu sene junior biyolojistler ve biyoloji öğrencileri uluslararası arenaya çıkacaklar.
Çok güzel. Ben çok destekliyorum
Onur gidecek
çocukları.
oraya.
Ben çocukları çok destekliyorum. Çocukları diyorum, onlar çocuk değiller. Onların hepsi gençler ama bizim çocuklarımızlar. O yüzden çocuklar diyorum. Yoksa hepsi genç birey. Kesinlikle yanlış anlayıp alınmasınlar. Amacım onlara küçük diye hitap etmek değil çocuklar derken. Ben hepsini çok destekliyorum. Herhangi bir konuda, hangi konuda olursa olsun, yardım istediklerinde ben yanlarındayım, arkalarındayım. Birçok konuda yardım istediklerinde onlara yardım edebiliyorum. Her kim isterse de buradayım. Çekinmeden gelip yardım isteyebilirler benden. Ben sohbet kısmına mail numaramı da bıraktım, mailimi de bıraktım. Oradan da ulaşabilirler mailime. Ee, Biraz daha öğrenci odaklı çalıştığım için ben, o yüzden öğrencileri bir adım ileriye götürmekte ve onlara danışmanlık yapmakta, resmi danışmanları olmasa bile e, dışarıdan danışmanlık yapmakta elimden geleni yapacağımı biliyorlar benimle olan öğrenciler.
Çok
Peki,
teşekkür ederiz hocam.
Halide
rica
Hocam,
ederim.
Meryem'e bir şey sorabilir miyim?
Tabii tabii.
Biyoloji bölümünden mezun olan çocuk o diplomasıyla gidip özel kendi işini kurabiliyor mu? Cezayir'de.
Tabii ya, ama mesela değişiyor yani diplomaya göre. Cezayir'de bir sürü biyoloji uzman alanı var. Yani mesela mesela e, ya değişiyor. Yani diplomaya göre. Yani lisansta biyoloji diploması yok. Şey oluyor. Yani yazıyor tam hangi alanda yapıldı. Yani ona göre iş kurabiliyorlar.
Daha çok Fransız ekolojisi mi, sistemi mi?
Evet,
Yoksa
evet, Fransızca. Bazı üniversitelerde nadiren Arapça kullanılıyor. Ama maalesef öğrenciler, yani benim öğrencilerimden söz etsem, Fransızca'ya hakim olan olmuyor. Hep zorlanıyorlar. Çünkü tabii normal ana dilleri değil. Ama herkes sanıyor ki Cezayir'de herkes Fransızca'ya hakim, ama bu yanlış. Yani bazı ailelerde Fransızca öğretiliyor genç yaştan. Ama son zamanlarda yeni nesil tabii artık hakim olmuyor. İngilizce de Fransızca gibi. Yani bence daha çok tabii üniversitede dil eğitimine daha çok önem verilmesi gerekiyor. Evet. İş konusunda tabii her yer gibi işsiz olan çok, yani. Bu normal. Ben bunu normal buluyorum. Çünkü öğrenci sayısı çok fazla. Mesela mezun olanlar, yani biyoloji dışında işsiz kalmıyorlar. İş buluyorlar. Mesela ilaç firmalarında çalışıyorlar. Satış temsilcileri olarak Cezayir'de bunu çok yapıyorlar biyologlar. İyi para kazanıyorlar. Onun için biyoloji mezunları genelde bu iş yapmayı tercih ediyor. Tabii onlara eğitim veriliyor satış ile ilgili. Ama hastanede, laboratuvarda herkes, yani çoğu o laboratuvarda çalışmak ister. Ama herkes çalışamıyor maalesef.
Bu da herhalde öğrencilerin eğitiminin yetersizliğinden değil, kadroların yetersizliğinden karşımıza çıkıyor Meryem.
Evet, evet. Ya mesela İngiltere'de mi dedi biraz önce, yani yetersiz kalıyorlar öğrenciler tecrübe konusunda. Mesela burada ben böyle bir şey genelde stajlara başlıyorlar hemen, veya öğrenciyken de gidiyorlar. Yani öyle tabii para almadan sırf öğrenmek için. Onun için tecrübesiz kalmıyorlar genelde. Tabii bu laboratuvarda çalışanlar, laboratuvar teknikleri öğreniyorlar, yani hızlıca öğreniyorlar. Tabii bunun için de sık sık gitmek gerekiyor, ilgilenmek gerekiyor. Onun için öyle oluyor. Ama bir şey eklemek istiyorum. Laboratuvar dersleri Türkiye'de bilmiyorum nasıl, Cezayir'de yetersiz kalıyor maalesef. Mesela daha çok teorik dersine önem veriyorlar. Laboratuvar derslerine tabii bu öğrenci sayısı da gittikçe de artıyor. Bunun için laboratuvar dersleri uygulama yetersiz kalıyor.
yani Türkiye'deki gibi yani. Değil mi?
Evet.
Türkiye gibi benzer.
Ben bilmiyorum, çünkü ben Türkiye'de eğitim sadece araştırma yapmaya geldim. Onu bilmiyorum. Mesela Adli Bilimler Enstitüsü'nde, Ankara Üniversitesi'nde öyle bir durum yok. Yani çünkü öğrenci sayısı az. Nihan Hocam'ın öğrencileri de uygulama yapar, yani kesin onu gördüm. Yani öyle Cezayir'de öyle bir durum maalesef olmadı. Ama belki farklıdır.
Halide Hocam, Mr. Wellen geldi.
Yes, welcome, Professor Dr. Wolfgang Nellen. Professor Nellen from Germany, and we will listen to the Professor Nellen. But first, dear Professor, please introduce yourself and talk about your research, please, because I read your CV on Wikipedia, and you have more investigations, more research, and please tell us.
Okay, hello, and thank you very much for the invitation. So what you now want is not my presentation yet, but just an introduction. Is that right?
Okay.
Is this already the time for the presentation?
Yes.
Yes.
Okay. So I should share my screen now. Is that right?
Okay, Mr. Ram.
Okay. Let's see. Where is it?
Under.
Still looking. Is that the... Yes, this is it. Okay. Are we here? Oops. Sorry. Yeah. Okay. Again, thank you very much for having me here. I will tell you a bit about my experience in teaching biology, just a little bit of background about what I've done in terms of research. I'm a molecular biologist. I'm a professor emeritus of genetics, and I've worked mostly on regulatory RNAs, that is gene regulation, a little bit of genetic engineering, basic research. It was all basic research at the university. On gene regulation, on a little bit on epigenetics, of course, a lot of teaching, and unfortunately also a lot of administration. What I'm doing now, I liked the teaching a lot, and I had started a lab for the public and for supporting high schools long ago. By now it's 20 years, 25 years ago that I started this, and I'm continuing this now as an emeritus. I'm no longer in research since, I'd say, 3 years, about 3 to 4 years, because I don't want to take the place of from the young people. When I stay at the university and continue teaching, continue doing research, I take away space and I take away money from the young people who followed me. Okay, so what I'll try to do today is to give you some idea of my understanding teaching biology, and the title is a little bit provocative. Holistic science is in quotation marks. Many people understand the word holistic different from me. Holistic means the overall field of biology. Professional idiots means that there are so many fields of biology that you may become a professional, but a professional who does not know the entire field or not enough of the entire field, and that's not so good. But let's go on. Okay, I have to do this disclaimer. I'm giving you my very personal view of teaching biology. It's not the only way. There may be many different other concepts and they may work as well. But of course, certainly I'm I'm very much convinced that mine is the best. Okay, don't take this too much serious. Let me start out with what I believe is a misconception of biology. Most people think this is biology. You have a cute little monkey on your shoulder, or your plant, a tree, whatever. The reality is different. It looks rather like this. And biology is both. It's the little monkey on your shoulder, the mouse in a cage, the plant that you're planting, and it's technology. It's everything. And this is one of the problems in biology. When you study math, you study math. When you study physics, you study physics. And the same for chemistry. When you study biology, you study math, chemistry, physics, and at least 20 subdisciplines of biology. So if you want to, this is halfway joking, but if you want to study something simple, go for math and not for biology, because biology is so broad, it's so wide, that it's a lot of work. So how to teach this huge, diverse field of biosciences? Important, the basics. And the basics are not really biology. The basics are math, chemistry, and physics. This is what you need to start out with. Then you have the holistic biology. That means get insights into the entire field of biology. And I've marked here, I don't want to go through this, and we can discuss which is important and which is not so important. Doesn't really matter, but you need an overview of almost everything in biology. And then you have the specializations. And again, we can discuss what is holistic biology, what is absolutely required, and what is specialization. One of the problems, at least in Germany, we have more than 1,000 specialized bachelor and master's curricula. And they are very specialized. And they give you the impression that you can specialize on something and forget about other things. You can't do biophysics without zoology, ecology without genetics, agriculture without microbiology, and so on. It's utterly wrong, because we need biologists who know biology, and then they should specialize. Just do bioinformatics does not really help when you don't know the biology. So this impression is, in my opinion, utterly wrong. Let's go through the different formats and what I think about the different formats of teaching biology. And lectures, the classic. Everybody has to go to lectures. A lecture is not just sending information. The lecturer is standing up in front and reading it was in the English universities, they sometimes call them readers, which means somebody stands up front and reads a text. Just reading a text, just lecturing, sending information is less than a textbook. Lectures are only useful when they are sending and the lecturer is receiving. Receiving means you have to watch your audience, you have to react to boredom, lack of understanding, and so on, and you have to adjust to it. Still, a lecture is a front to back thing. I believe it's still required. We need this. And there should be questions allowed, of course, but they have to be limited and well managed so that you don't that you don't spend your time answering questions and not proceeding with the content, with the information that you try to send. Questions, there is enough, should be enough room in tutorials and seminars. Especially with Corona, digital lectures and courses have become very, very popular. And of course, they are a valuable extension of textbooks and may include formats that have not so much been used in the standard lectures. You can even have lab simulations. But you also have to ask the question, do we really have to do that? You are at a distance to your audience, and why do you have to do this? There are so many excellent lectures online, so why do it again and reinvent the wheel? So you really have to ask the question, am I really needed for an online lecture? I may hire the most excellent biologist from whatever country, buy a lecture from this person and just send it to the students. So you don't even have to do it. But biology is teamwork. You can use digital courses and lectures as an extension, but biology absolutely requires teamwork between different specialists. It means interaction between people. And of course, it means interaction between people and the object, that is nature. And this is the topic of biology, right? And this can only be trained in live courses. Online communication is essential, but it only works efficiently when people really have live interaction. And well, for lecturers, you can think about it once you have established a lecture, it's easy. You can just stream it and go out for a walk and have coffee or whatever, but you lose the contact to the students. Seminars. Seminars are interactive work in small groups. And the top photo is not really a seminar. It's more like a lecture. The lower one is more like a seminar. It's more interactive. It's time for asking questions. It's time for reading scientific papers or presenting projects. And it's always a change in perspective. You have the scientific level, and an important part of seminars is also various levels of science communication in between experts and learning students, between experts and the public, and so on. There are several topics or several side aspects that can be covered or should be covered in seminars. That's bioethics, which is frequently neglected, social impacts of biosciences. It can be done in role games, and there are several very, very good examples for role games. I like one very much, which discusses gene drive against malaria. It's a role game that was developed by an institution in Germany, and it's excellent and excellent training for students. Another one is the nature of science. This expression, nature of science, is coming up in Germany. I don't know what it is like in Turkey, but in Germany, it's becoming famous, it's becoming modern. And it means, what is science like? And when you look at many students or students at universities, but also at high schools, what they are taught about science is sometimes pretty much off the track. They don't really know what science is. They do some experiments, whatever, but they don't have a real idea how to deal with science and what the practice of science is. I'll show you in a second. I think one very good project in a seminar is to discuss really bad papers. Give your students a paper which is so bad that you don't really want to read it, but they have to see it and they have to identify that a paper is bad. And I have an example here. It's really a very, very good, bad paper. It's on COVID-19 and on the risk of getting prion diseases because of vaccination. It's absolutely stupid. And it looks like a good scientific paper. It looks like a paper. It has an introduction, it has methods, it has results, it has discussion, it has references, whatever. But when you go through this paper, you find almost everything that you can do wrong in a paper. Methods are incomplete and misleading. There are no data shown. This is the entire results section of this paper. No single figure, just assumptions. There is no evaluation of significance. There are facts that are ignored, knowingly ignored. There are conclusions which are not based on any findings, but it's really an excellent example to discuss with students why not only tell them this is a bad paper, but why is it a bad paper? And I think this is something which is a little bit lacking in science. What is a good, how do you recognize a good paper? How do you recognize a bad paper? Another format is tutorials. And I have always used tutorials to identify good students, because the students do the tutorials, they discuss more advanced good students, repeat the content of lectures, explain and start out with something which is extremely important, that is transfer questions. And transfer questions is what I like in tests. So they are preparing for tests and train combinatorial thinking between the disciplines of biosciences. Tutorials have for a lecturer, for a lecturer, they have a double value. They give you further training for excellent students, and they help you identify really good students that you would like to recruit to your lab for a BSc, MSc, or a PhD thesis. This is a tuition book. It could be good. And this one is, of course, extremely good because it was written by some of my students. And I'm extremely proud of it that they managed to get this book published. But teaching face-to-face is definitely better. You can still buy this book. It's in German, but you should buy it because my students get a small part of the income. But I think tutorials should be face-to-face. Let's see, what do we have next? Next, the most important thing in biology is courses, lab courses. They give training for technology in the respective subdiscipline. It's first time for hands-on experience. They have to know methods, they have to know instruments, they have to know how to set up an experiment. What has to be stressed, just explaining what science is to the students, a lab course is no research. A lab course is no experiment in the strict sense, because you know the outcome. It is just reproduction. And the students should know that. Otherwise, when they do science, when they do research, they will come up with the sentence, the experiment did not work. This is the most stupid sentence that you can say. An experiment does not have a predicted outcome. An experiment is something where you're testing a hypothesis and you get an answer. Maybe you made a mistake, but experiment is an experiment. In a reproduction, you can say it did not work. You can do troubleshooting and ask the question, why did the experiment, in quotation mark, not work as expected? It worked somehow, but not as expected. So you can ask that question. There are examples for, let me see, there are examples for few examples for experiments where students can really have a hypothesis and kind of self-direct their experiments. One is this, it's on DNA hybridization. You give them different fragments of DNA oligos or DNA oligos with high and low AT content, and they can watch double helix formation and denaturation. That can be easily detected with this kind of fluorescence viewer. You melt the DNA, fluorescence disappears because the dye only binds to double-stranded DNA. You bring back to room temperature, and with time, the fluorescence comes back, and you can ask questions or make the students set up a hypothesis. Is there a difference between AT-rich and GC-rich DNA? And if so, why? Is there a difference depending on DNA concentration, on temperature, on DNA complexity, on pH? They can come up with all these questions and they can directly test this in an experiment. So this is really hypothesis-based tests of hypothesis-based experiments to test this hypothesis. I like that one. Advanced lab courses, they are usually, and I used to do that mostly, they are usually integrated into a project of the lab. So the students are introduced to a small part of a lab project and they are working on this more or less successfully. It helps to motivate and finally recruit the good students for a thesis work. But what is often required, or what people in didactics are asking for, is self-determined projects. And these are difficult. They're almost impossible to establish a self-determined project. They require a lot of experience, knowledge to ask a question, a scientific question. We have one example that we have developed with the BioViscom a while ago, and this is an experiment knockout of beta-galactosidase gene in E. coli by CRISPR-Cas. And what we found by establishing this experiment, which works almost, but not completely perfectly, is that 0.1% of the colonies, and that's what you see here on the right, in 0.1% of the colonies, the experiment did not work. And that was the interesting question. What happened in this 0.1% of the colonies? Why did the CRISPR-Cas not work? And this finally turned out to be that could be used as a self-determined project for an advanced student to set up a hypothesis, do an experiment, find out that the hypothesis is wrong, set up the next hypothesis, do the next experiment, and you actually find an answer. I don't give you the answer now because you can also use this experiment. But there is not only one answer, there are multiple answers. And you can keep students playing for 2 or 3 weeks in the lab, in a self-determined project, and they may find out. Another important part in teaching biology is excursions. Field work is essential because biology happens in the field, at least most of it. And even young biologists who will spend the rest of their life at a computer, they should get an impression of field biology. And they should learn that E. coli does not grow in temperature-controlled shakers. They usually live somewhere else, mostly in the gut, but also in other places. Mice usually don't live in cages, and Arabidopsis not in potting soil with controlled illumination. People forget this. Believe me, they really believe that Arabidopsis grows in the greenhouse and they don't recognize it when it grows in their front yard. So what you're looking at in the lab is not living under natural conditions, but it's a controlled monoculture outside its ecosystem. And students should get at least a rough idea of ecosystems where their research object is living and how it's usually interacting with the environment. Tests, exams, no way around it in teaching. They are considered really scary by the students. But they could rather be rewarding and point out strengths and weaknesses, not only to the lecturer, but also to the students. And I believe there are many mistakes in doing tests and exams. Knowledge is important, but knowledge by itself, you identify people with good memory and not necessarily scientific talent. What I hate most is multiple choice tests, and I give you a somewhat exaggerated example, but it's not so much exaggerated. A question like, which of the following statements cannot be considered incorrect? So double negative questions, they are not asking really for biology, understanding biology. They are asking for understanding grammar, semantics, language logic, and not biology. Or take something like this. The answer is A and C, A or B, C and D, but not A. I admit this is exaggerated a little bit, but in principle, in most cases, or in many cases, you're not asking understanding of biology, you're asking understanding sentences and the construction of a sentence and combinatorial things. Transfer questions, in contrast, require knowledge in itself and the application of knowledge. And I give you an example. Sorry, it's again on CRISPR-Cas. And the question is, CRISPR-Cas in the germline is the easiest and most efficient way to eliminate or monogenetic diseases in humans. Is this true? Is it not true? And why? Or you may give a little bit of help and say, are there alternatives that are ethically and technically less difficult? This requires knowledge, different points. How does CRISPR-Cas work? What is the efficiency of a gene knockout? And what are off-target effects? And so on. Mendelian genetics. And in the end, the answer, many people at the first glance will say, yes, this is why we are doing CRISPR-Cas, to eliminate hereditary diseases. And the answer is no. But when students go through this and they have the basic knowledge of these things, they will find out that it's much easier to eliminate these diseases by genetic counseling or by in vitro fertilization, prenatal diagnostics, and or even abortion. It's much easier and ethically easier than less problematic than doing CRISPR-Cas. So there is a wrong understanding, and they will find out when they have the knowledge. So you need knowledge, you need combination, and then you can find an answer. And it's a real challenge to ask such questions, but I think it helps. I'm coming to the end. Other formats on curricular requirements. What is neglected in many cases are these formal things like good laboratory practice, good manufacturing practice. All these things are important when people go into industry. There should be a recommendation to do a semester outside the usual university, abroad in other countries. Internships in industry. There should be career workshops, and people should be motivated to present stuff, their work at conferences. Well, and this is what I wanted to tell you. Just briefly allow me a little bit of advertisement. What we are trying to do is to help with different teaching formats. You're welcome to contact me under this address, and we can talk whatever you want. We do almost everything, not quite everything, but almost everything. So I thank you very much for your attention, and you're welcome to ask questions if you want. Thank you very much.
Thank you very much, Mr. Velen.
Yes, your presentation is perfect and understandable and clear. Your English is very, very clear. And thank you for this. And I want to say something. Yes, you are right. Without experiments, one cannot learn anything in biology. And I think experiments cannot be taught at online platform, but all the worlds do it. I think in this conditions, in the corona conditions. I'm with you. Tutorials must be face-to-face, absolutely, and discussions is necessary. All the students and I think even teachers. And I want to say in my classroom, students have to read at least one article and present it to us for passing the class. It is, I think it is necessary for them. And I want to wait our listeners, I want to wait your questions to Professor Dr. Nel.
YouTube'da herhangi bir soru yok hocam.
Don't be shy. Ask.
We have no question on YouTube, and I think there is no question on Zoom, but only one student want your email. I think he gave it first page. On
Email you can use. Wait a second. Where is it?
Yes.
Is the PowerPoint is still open? Yeah. So info@biobiscom is fine.
Okay.
This email address is fine. Gets directly to me.
Please, if it is possible, send us your presentations for our report, workshop report. We want to use it in our.
Okay. Okay. Yeah, but it's okay. You can have it for your report, but not used for anything else, right? Is that okay?
No. Only for reports. Yes,
yep.
Of course.
Okay. I can send it
okay.
as a PDF. Yeah.
Okay.
Okay.
Thank you for our speakers and participants. And I think I have to close this session. Because Professor Dr. Ramiz Shamadov cannot come to the platform. Is he here? No. No, okay, we close the session. Again, thank you, Professor Dr. Wolfgang Nellen and Associate Professor Dr. Meryem Talep. Thank you for their presentations.
I thank you and much success with the rest of the meeting. Thank you very much.
Thank you very much, Mr. Euler.
You are welcome.
Welcome again. Arkadaşlar, ikinci günün sonuna geldik. Onur, sunumu kapatabilir misin ya?
Kapatayım hocam, bir dakika.
Dur, ben de kapatabiliyorum.
Kapattım hocam.
Tamam. Yarın birinci gün ve ikinci gündeki oturum başkanları bir rapor sunacaklar. Yani bir özet rapor sunmaları lazım. Rapor sonuçları saat 9.40'da başlayacak. Arzu ederseniz biraz erkene de alabiliriz. Birinci gün ve ikinci gün raporlarını takdim ettikten sonra üçüncü gün oturumuna başlayacağız. Bu bakımdan YÖK ve Milli Eğitim Bakanlığı'ndan herhangi bir cevap gelmediği için ve herhangi bir şekilde de bir sunum göndermedikleri için onların konuşmalarını es geçeceğiz ve biz 9.40'da raporla ilk iki günün raporu olarak birinci ve ikinci gün sunucuları ve oturum başkanları birer ufak sunum hazırlarlarsa raporla ilgili, o günle ilgili, oturum başkanlarıyla kendi oturumlarıyla ilgili bir paylaşım yaparlarsa üçüncü güne dop dolu başlayabiliriz. İkinci günle ilgili soru sormak veya yorum yapmak isteyen arkadaşlarım var mı acaba? Yanılmıyorsam yok.
Ben yorum yapabilir miyim?
Yapınız, buyurunuz.
Sayın Wolfgang'ın konuşması çok güzeldi. Gerçekten hani ben raporumda da belirteceğim ama biyoloji nedir ve biyoloji nasıl öğrenilir, nasıl öğretilir biyoloji, çocuklar biyolojiyi, öğrenciler biyolojiyi nasıl öğrenirleri o kadar güzel anlattı ki ben o sistemi beğeniyle izledim. Bugünkü sunumların her biri birbirinden güzeldi ve gayet aydınlanmayla bittiğini düşünüyorum bugünün ve özellikle gençlere çok güzel ipuçları verildi sabahki ve öğleden sonraki oturumlarda. Herhangi bir soru oluştuğunu düşünmüyorum akıllarında ama oluşursa yine de bu platform içinde hala bizler buradayken onlarla birlikte istediklerini sorabilirler diye düşünüyorum. Yarın da katılımın büyük olacağını düşünüyorum. Teşekkür ediyorum.
Nihal, biz sana teşekkür ederiz. Yoğun programın arasında görev aldın en azından. Desteklerin için ayrıca ben özel olarak teşekkür ediyorum. Aslında tüm gönüldaş ve görev alan tüm arkadaşlarımıza ilk 2 günü sorunsuz ve kazasız geçirdiğimiz için hepsine ayrı ayrı teşekkür ediyorum.
Ben de teşekkür ederim.
Biz teşekkür ederiz hocam bize kattıklarınız için.
Vallahi
ederiz hocam.
dükkanda bulunan bunlar arkadaş. Başka bir şey yok. Ne varsa sizin, bizim değil. Evet, güzel işler yapıyoruz arkadaşlar. O konuda bir işimiz yok. Yarın 9.40'da başlayacak. Ben yine 9 çeyrekte açarım. Oradan devam ederiz. Herkese iyi akşamlar diliyorum. Yarın görüşmek üzere.
Görüşmek üzere.